So in this video, I'd like to show you how to convert this masked binary image into an object model. And I'm about out of steam um, on my microphone and buds here, so we'll see. This might be the last video I make tonight. But the basic idea is that what we have right now is this layer that's saying true or false. Is this a core grassland habitat? Right? Is it an open habitat that's at least 50 meters from um, closed canopy or structural habitat or development? And and so in a way, it's kind of an archipelago of grassland cores. And what I want to do is start kind of distinguishing the different islands in this archipelago. I want to be able to say that this is one grassland, this is another, because the criteria that the state has presented uh, based on the area and the perimeter to area of these core habitats kind of relies on the object model. So we're going to need to get from this archipelago into islands. And we're going to do that in Earth Engine by converting this raster into a feature collection so that each contiguous region of, of the raster here will get converted into a feature in a feature collection. And it's going to be those features that allow us to represent objects in 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 Earth Engine and at least in this approach that I'm going to show you this week. So let's grab the snippet. I'm going to go over to the primer and grab the snippet for this. Grassland objects is the container that we're going to kind of store the results. Grassland cores is the input, so I'm going to say is equal to this. And then the method that we're going to use is over here someplace. It's called reduce to vectors. And when you look at it, you're like, oof, no, no wonder the earbuds are about to give up. Like, look how much junk there is here to kind of get through on this method. So let me just type in dot reduce vectors because that's the name of the method, and then let's give it the parentheses because we need to feed it some of these arguments. There's so many of them that I'm going to use a dictionary approach to store them, and I'm just going to go ahead and copy um, this long list, click and drag, right? And then paste it in the dictionary here, and then let's start working through it. So the reducer is the first thing it's asking for. If we look at the um, instructions here, you can see that the default is count every. Um, we don't have to worry about this too much, other than like we can use the default here, and I think it'll be fine. We want to count every pixel and that's contiguous in this region, and we may get a statistic about how many pixels are in there, but that's fine. It's not a big deal. The geometry is going to be basically the extent that it has to work over. Earth Engine is in a way like it's always a little bit lazy. It's trying to get out of doing work if it can. So it's saying with this, like, what's the region that you want me to deal with vectorizing? And so we want it to be the study region, right? So we could probably say bounds here, and that's going to say just work on this in our study region in our bounded extent that we defined in step 3. So for scale, I'm going to say work at kind of the 1 meter scale. So I'm just going to say 1 as our scale. For geometry type, it's asking us, what kind of geometry do you want to kick out of this vectorization process? Do you want me to give you the centroids? It's trying to figure out what it needs to deliver here in terms of the geometry type. So we're going to go for the polygon um, enclosing the pixels, and so I'm going to say that to get us polygons and make sure that comma is close because sometimes that can matter. 8 connected. So I didn't mention this at the Blackboard today. I'll draw it out on Thursday. But it's basically trying to figure out what our rule for adjacent, like contiguity is or adjacency. So it's asking here, um, do you want diagonals to count? If a pixel touches another pixel on a diagonal, should it be part of the same object, or do you want me to split those into two different objects? When you're dealing with high resolution data, I usually think that it's better to say true for and allow diagonals to count as touching, basically. So for label property, I think we can just leave that off. I think if I look at label property, it's the first band was saved to the specific property of each feature. That's fine. We've only got one band. So in our case here, I'm going to say null. It doesn't really matter. CRS, yes, please do this in our coordinate reference system that we stored up here. Like I'd like to do this in EPSG 32145 if you don't mind, Earth Engine. Thank you very much. I'm going to not worry about the transform or the best effort, but max pixels I am going to worry about. I'm going to say, please use 1E12 because I think that's about the max that Earth Engine will kind of work with. So when it says max pixels, the maximum number of pixels to reduce. And I'm going to say do as much as you can, work with that many pixels. And if you have more than that, you can tell me that you're tired and don't want to continue to do it. Tile scale I'm going to ignore for right now, so delete that. And then geometry and native projection. Let's go ahead and look at this and create geometries in the pixel projection rather than WGS84. Sure, that sounds good. This might slow it down a little bit, but I'm going to just say true. That sounds that sounds that sounds like a nice thing to do. I've already told you to do this in in this coordinate reference system, but I think what it's saying is, do you want me to store the coordinates of the polygons in this rather than WGS84, which is another coordinate system? So I'm going to say true. Okay, thanks very much. Go ahead and do that. And then let's go ahead and look at this grassland objects, get this set up to be able to display. Remember the output, reducing the vectors. So we're going to be looking at a feature collection, which means we have to say color. For color names, I think I'm just going to go, beige on this one. Um, and, you can pick another one if you'd like, but just remember you have to put it in strings. And then this is going to be my grassland objects. And I'm going to say false here. I'm going to save this and then run. And then what do we get out of this? So I'm gonna click this on, and I think it's gonna take a little while. That bar is it might take a few seconds here, so I may not just hang. Oh, cool, it popped right in. So there are the grassland objects, and that we've kicked out, where we've taken these um, grassland cores with masks and basically reduce them and to these objects. Is that fair? And so you might be looking at this and be like, well, it seems like there's a lot more white than is popping in, but and that the it seems like uh, but that's kind of the thing. If you keep zooming in, you should see that the vector actually corresponds pretty well with the the underlying data as you zoom further and further in and get closer to this 1 meter resolution. The one thing that you'll notice is that the buff the buffers seem to be a little bit more aggressive here, and that has to do, I think, with us having turned this off at this step. So we'll fix this moving on, but don't be too surprised that the distance-based constraint that we did looks a little different from in the raster and the polygons. Um, and also don't be surprised if the underlying raster seems to change as you scale out, because we've always talked about that. these features are going to be resilient to scale as you zoom in and out. They shouldn't, I don't think they'll change much. Maybe the detail of the edges changes, but they don't kind of change as much as that underlying raster. Is that fair? So, okay, so we've got our objects, and I've saved, and I think I'm going to call it a night and then try to wrap this up in the morning, but we're doing pretty good. We just finished step 12. So, see you tomorrow.